This is College Algebra, Unit 2, Section 2. On these graphs, you need to find the X and Y intercepts, make a table of greater than or equal to 5 points, 5 ordered pairs, state any extra restrictions. I don't believe there's any restrictions for X. You can put all real numbers in all of them. And a graphing calculator is very helpful. Knowing how to put in the equation under y equals and then graphing it by hitting the graph button, and then after you've graphed it, then you can go to the table and find values for the table. Okay, there's going to be number 1, y equals negative 3x. That is a line. Number 2, y equals 1/2 x minus 2. Notice I put 0 in for the y, found the x-intercept. Then I put 0 in for the x and found the y-intercept. Notice my table of points, quite a few points there, using a calculator, a graphing calculator, by finding y equals, putting the equation in there, and then I typed in y equals 1/2 x minus 2, then I hit graph, then I hit table. Then I plotted the points. It just took 2 points to graph it, because it was a line. Number 3 is an absolute value equation. Y equals the absolute value of x minus 3. Then outside the absolute value, minus 2. Those are always V-shaped. Number 4, y equals x squared minus 9. When you have a squared in it like that, it's a parabola, opening up because it's positive x squared. Then I found the x-intercept. I found the y-intercept. I also found the vertex by using negative b over 2a from the equation. The b from the equation is 0 because there's no x term, over 2 times 1. So 0 over 2, so 0 is our x coordinate of the vertex. Then I put that back in the equation and found the y coordinate, 0, 0. Okay, then all of those points there. Please look at that. Number 5, okay, y equals x squared minus 6x plus 8, parabola opening up, same thing that you've been doing. Now I kind of got offline here, and on number 6, if you look at that table there that I scratched out, that table is actually for number 5, so it could be helpful to you on number 5. But number 6 is 3 minus the absolute value of 2 plus x. Since it's minus the absolute value, it's going to be V-shaped down. Okay, the absolute value are always V-shaped. Then, notice I found the x-intercept by putting 0 in for the y. And then I found the x-intercept by putting, the y-intercept by putting 0 in for the x-intercept by putting 0 in for the y. And the y-intercept, well, those are both x-intercepts. There. X-intercepts. And then the y-intercept is right here. Okay? The vertex of an absolute value graph is found by taking the 2 plus x inside the absolute value, putting it equal to 0, then solving that, x is negative 2, and then putting the negative 2 back in the equation to find the y value, which is 3. That is our vertex. That's where it turns. That's very important. Number 7 is y equals x plus 1, a line. Number 8, another absolute value. Y equals the absolute value of 2x plus 1 in the absolute value minus 3. Then all of the steps are shown there. X-intercept, I went through that. I made it 0 equals the absolute value of 2x plus 1 minus 3. Then I did the work of solving that absolute value equation like we did back in the first chapter. X is negative 2 and 1. The y-intercept found by putting 0 in for the x. Okay? Remember, the vertex also is found by putting that 2x plus 1 equal to 0, and then solving it for your x is negative 1/2 for the vertex. Then I put negative 1/2 in for that x and found the y coordinate, negative 3. That's the vertex. That's where everything turns. That's a very important point. Okay, number 9 is y equals x cubed, a different type of graph. It's going to look like this one below, kind of. Okay, only it's for number 10. And then number 10, okay, we find it by the x-intercepts on this cubic polynomial, x cubed minus 4x. So far we can find by factoring. And we found the x-intercepts, 0, 2, and negative 2. 3 x-intercepts, the same as the power of the equation, x cubed. Then we find the y-intercept by putting 0 in for the x, 0, 0. Then my table, I found those by putting y equals in the y equals x cubed minus 4x into the graphing calculator. Made it very easy. Or you have to go through and put them in by hand so you find those values. Number 11 is another parabola. I didn't finish it. It's in the back of the book, but it's going to look like that because it's a negative x squared. Number 12 is going to look like that. Okay, please go through and do all of the work there. I factored it. I moved everything. I put 0 in for the y and moved everything to the left side so I'd had a positive x squared, and then I factored it. That's how you find your x-intercepts usually on cubes and squareds, parabolas, and your cubic polynomial. Then I found the y-intercept. Then I made my table. Again, your vertex on a parabola is negative b over 2a. Our b is the number in front of the x, 1. 1 over 2 is your x coordinate. Then I put 1 over 2 in here and found it was 6 1/4. Number 13, y equals 3 is just a horizontal line. 14, x equals negative 2 is a vertical line right here. When you only have x, x-intercept, negative 2, 0. No y-intercept. And the slope on a vertical line is undefined. Then number 15 is a cubic polynomial, which you do the same way as our other cubic polynomials. Okay, that concludes lesson